Lesson 16, Multiply Fractions in Word Problems. In this lesson, we're going to talk about multiplying fractions and multiplying mixed numbers. Let's start off with a basic problem. This is from your homework or classwork. 2/3 of 3/8. Okay, the first one I'm going to do is an area model. So first I start off with a box, and my denominator tells me I need 3 pieces, and in those 3 pieces, 2 of them are going to be shaded in one direction. So I'm going to go this way, 1/3, 2/3, all done. Then the other denominator tells me I need 8 pieces. So I'm going to do my best. 1, 2, 3, 4, 5, 6, and 7. Got a little choppy there. And 8. There we go. And this time, I'm going to go the opposite direction and color in 3. So here's 1/8 all the way across, 2/8 all the way over, and 3/8. And if you remember from previous lessons, we're focusing where it crisscrosses. So I'm going to highlight it for you so you can see it clearly. So I see a crisscross here, and here, and here, and here, and here. So I should only have 6, that's right. And you can even check your multiplication on this. It should match. It should match. 2 times 3 is 6. 3 times 8 is 24. So 6 pieces, 1, 2, 3, 4, 5, 6 pieces out of 24 should be shaded in or crisscrossing. So that's one way to show your work, is by doing an area model. Yours should be much neater than mine. Mine is very messy. Here we go. Let's think of another way to show this. Here's another way. We're going to use a number line. We're going to do 2/3 of 3/8. Usually, I would like for you to start your model with whatever is first. With the number line, we need to know 2/3 of 3/8. So we need to draw 3/8 first so that we can take 2/3 out. So let's start with 8s. 1/8, 2, 3, 4, 5, 6, 7, and 8. We only want to know about 3 of them. So 1, 2, 3, 8 is right there. Let me put a label on it. 3/8. Okay, out of those 3 pieces right here, how many should we shade in? It says 2/3 of 3. So I'm going to get my highlighter and shade that in. Here's 1/3, and there's 2/3. I do not need to color in this last third because it didn't ask for 3/3. It asked for 2 of them. My answer is going to be 2, because only 2 of them were shaded. And how many pieces did I have in all? Well, here's 1, 2, 3, 4, 5, 6, 7, and 8. So 2/8. Now I know you're thinking, how do you have 2 different answers for the same problem? 6/24. I'm going to show you. 6/24. When I divide them both by 3, will get me what fraction? Well, 6 divided by 3 is 2. 24 divided by 3 is 8. They're the same thing. When you divide by a number equal to 1, you're going to get the same thing all over again. 6 24ths and 2 8ths are equivalent fractions. They actually take up the same amount of space in the world. They're actually the same thing. So depending on your model, you may get a different answer than your partner or your friend or your sister. So choosing a model can change the way you see your fractions. But they're both correct. 6 24ths and 2 8ths are the same thing, so they're both correct. So we have two options, an area model or a number line. The number line gives you a smaller looking fraction. It looks smaller. The numbers are smaller, but it's not really smaller. It's the exact same thing as your area model. Okay, here we have a word problem. And as always, I'm going to do cubes. At noon, Ada and Kent had 3/8 gallon of lemonade left at their lemonade stand. The next customer bought 1/3 of the remaining lemonade. How much lemonade did the customer buy? Start off with your C. What numbers do we see? 3/8 of a gallon and 1/3 of what was left over. Underline the question. How much lemonade did the customer buy? Box the math action word. It's a tricky one, this, but it's actually of. I could understand if you thought remaining and left. They kind of go hand in hand. I could definitely see if someone chose left and remaining for subtraction. In a way, we kind of are subtracting. In this context, so in this story, of means division. We want to know what the customer bought of the remaining lemonade. Let's set up our equation. We want to know what is 1/3 of, hold on, let's do that the other way. We want to know what is 1/3 of 3/8. So we want to know what is, goodness, I am getting so confused. 1/3 of 3/8. Oh, this is not division. I'm so sorry. In a way, we are dividing, but in a different way. Of means multiply. Sorry about that. When you see the word of another number, it's going to mean multiplication. Showing our work means pick a model to show. I know that we can just do the multiplication. 1 times 3 is 3, and 3 times 8 is 24. I know we can just do that, but please show your work so that you can get full credit. This time, I think I would like to do a number line. So they had 3/8 of a gallon left. So 1, 2, 3, 4, 5, 6, 7, 8. So they only have 3 left. So here are the 3/8 that were left in their lemonade stand. The next customer bought 1/3 of that. So only 1/3 of this. How much lemonade did the customer buy? Well, they bought 1 of how many? How much was there at the very beginning of their lemonade stand? 1 2, 2, 3, 4, 5, 6, 7, and 8. So the customer bought 1/8 of a gallon. Because I chose the number line model, I ended up with the smaller numbers, but they are the same value. And let's prove that again. If I divide both of them by 3, so dividing by 1, what do I get? 3 divided by 3 is 1. 24 divided by 3 is 8. So 3/24 is equivalent to 1/8. So both answers are right. If you do the area model, you'll get this answer. If you do the number line, you'll get this answer. But they're the same thing. Write the missing numbers to complete the multiplication equation, showing how much of the deck is painted. Multiply the length and width of the painted area. So this problem is when we get into our mixed numbers for the first time. I'm going to show you 2 ways to deal with mixed numbers, and you'll just pick which one you like better. In this first problem, they simply split the mixed number up. So I'm going to help you by putting these parentheses in so that you can see the different groups. So they're going to put the 3 in this box and the 1/5 in this box. So instead of multiplying by 3 and 1/5, you multiply by 3 for one section. Oops. And you're going to multiply by 1/5 in the other section. So it's kind of just letting you take your time and figure out one piece at a time. So we're putting 3 in its own section and then 1/5 in another section. So first thing I'm going to figure out is, what is 3 times 3 times 2 thirds? Well, 3 times 2 is 6, so I would have 6 thirds in total. And I put the 6 right here on top. My next question is 1/5 of 2 thirds. 1 times 2 is 2, and it's already there. What's 5 times 3? 15. Oh goodness. This box is too small. It's hard to draw. 15. We're doing our best. Okay. So here we have 6 thirds plus 2/15. The 2/15 is already sitting there waiting for you. What is 6 thirds? What is 6 divided by 3? Or how many groups of 3 are in 6? If I don't know, I can use my denominator and subtract until I get to 0. So that 6 minus 3 is 3. I'm going to subtract 3 again. And that gets me to 0. So how many groups of 3 were sitting inside 6? 2 groups. So when we multiplied them, it was 2 and 2/15 square meters. So one way of dealing with a mixed number is having the fraction, figuring out what's going on with the fraction, so multiplying the fraction and getting that out of the way, and multiplying your whole number. And when you have those two things, you add them together to get your total. Let's move on and look at the next way. You might like that one too. Here's another way to multiply. First, we're going to rewrite 3 and 1/5 as a fraction. So right now it's a mixed number. We're going to turn it into an improper fraction. 3 and 1/5 would be 3. 3 wholes and 1/5. Well, how many fifths are in 3 wholes? So if I did, remember we were doing this. So that's 5, 5, and 5. Oh, there's 15 in there. There are 15 pieces in there. And we bring down our 1/5. 15 plus 1 is 16 fifths. So now we can use 16 fifths instead of this number, instead of the mixed number. Sometimes improper fractions are just what we need. 16 fifths times 2/3, or 16 fifths of 2/3. So we have 16 fifths and then 2/3. So we want to know, what is 16 times 2? Well, I'm going to use addition for that. 16 2 times is going to give us 32. So we have 32 15ths in all. Well, how many 15ths are in 32? Because now we need to give it, and we need to turn it into a mixed number. So 32 minus 15. I can't take 5 from 2, so I'm going to decompose and turn that into a 12. 12 minus 5 is 2 minus 1 is, I can still take another 15 out. 7 minus 5 is, and 1 minus 1 is. So we have 2 groups of 15 with a remainder of 2. The 2's already there. They already gave the 2 wholes. And we had a remainder of 2. And that goes right on top. So 2 and 2 15ths. Whichever strategy you use, stick to it and be really good at it so that you get the right answer each time. So the 2 methods were: change the mixed number into a fraction, which we've kind of already been doing for a while now, so you might like it because you're familiar with it and comfortable with it. The other one was to split them up and take it piece by piece. So multiplying by the whole number first, then the fraction, and then adding them together. You make the decision which one is better for you. This has been Lesson 16, Multiply Fractions and Word Problems. In this lesson, we talked about multiplying by fractions and multiplying by mixed numbers. Thanks for watching.